Welcome to lesson number 4. We're going to be looking at difference of squares. To begin our investigation, we're going to complete this table using trinomial factoring from previous lessons. So if I have two integers that have a sum of negative 16 and a sum of negative 6 and a product of negative 16, those integers are probably going to be negative 8 and positive 2. In factored form, this would become x minus 8 and x plus 2. For a product of negative 16 and a sum of negative 15, we're looking at negative 16 and positive 1. Something like this would have a factored form, first of all, of x minus 16 and x plus 1. And then when we expand this, we get x squared minus 15x minus 16. Now, when we look at something like this, there's a sum of 0 and a product of negative 16. And so there's no middle term here. You see how that is 0x. There's no middle term, so x squared minus 16 equals x squared minus 16. Then what this means is this is going to have a, negative 4 and positive 4. So a sum of 0, negative 4 plus 4, and a product of negative 16, negative 4 and positive 4 multiplied is negative 16. And if we were to take a look at what this, if we were to simplify this, so this is simplified over here. So x squared plus 0x minus 16 equals x squared minus 16. In factored form, this is going to become x minus 4, x plus 4. In number 4 here, we have a product of negative 64 and a sum of 0. So we would have negative 8 and positive 8. And as a polynomial, this would look like this, x squared minus 64. And in factored form, we would have x minus 8, x plus 8. Here, a product of negative 25, sum of 0, negative 5 and positive 5. This would be x squared minus 25, and in factored form, x minus 5, x plus 5. So the third row in A shows that the factored form of x squared minus 16 is x minus 4, x plus 4. We want to use the pattern from above that emerged in the last 3 examples to factor the following. And so all we're doing is we're taking the square root of this, and when we do that, we would get x, square root of x squared is x, and square root of 9 is 3. But we're also going to have x plus 3. And I'm going to write them down here so I have a little bit more room. Here I would have x minus 7, x plus 7. Square root of 49 is 7. Square root of 36 is 6. So I'd have x minus 6, x plus 6. And square root of 1 is x plus 1, x minus 1. And it doesn't really matter which way which sign you put first. You could write it like this, x plus 1, x minus 1, or x minus 1, x plus 1. It doesn't really make a difference. So if we were to extend the procedure above for m squared minus n squared, we want to verify our answer after by expanding the factored form. So using the same reasoning, this would be m minus n, m plus n. And if we were to expand this, we would end up with m squared plus mn minus mn minus n squared. These two terms would cancel out, and we would be left with m squared minus n squared. Now, in this expansion, x minus y, x plus y, we want to explain why the value of b is 0. Well, the value of b is 0 because if I were to FOIL this and use my distributive property, then I would get x times x, which would result in x squared. I would get x times y, which would give me xy, and that's positive xy. But then I would get negative y times x, which results in negative xy. And that's where those terms cancel out and we're left with 0. And so express c in terms of y, c is going to be equal to y squared. So the examples on that previous page are called difference of squares. And in difference of squares, b is 0 and c is always a negative square number. So this results in a difference of squares such as x squared minus 25 or x squared minus 100. See, a negative square number, negative square number. So in order to factor differences of squares, you can identify the a and the b value, take their square root, and one will be negative, one will be positive for your b. This one and this one. So the square root of t squared is t, and square root of 144 is 12. So we would have t minus 12, t plus 12. And then something like this, p squared minus 7 squared, where 7 hasn't been expanded to 49, we would write this as p minus 7, p plus 7. One important thing to note with the difference of squares is that it's not possible to factor a sum that almost looks like a difference of squares. So x squared plus 4 and x squared plus 0x plus 4. These are not factorable. The difference of squares, notice how we have a subtraction sign. That's also referred to as the difference of two squares. So this is a square number, this is a square number, and there's a difference between them. Now for the following, we're going to factor if possible. Right away, you can look at this one and know that this is not possible. So not possible. If we look at the other ones, so 16t squared minus 49, that's possible. This would result in 4t minus 7, 4t plus 7. We have a perfect square and a perfect square. So this would result in 6p minus 5q, 6p plus 5q. 81a squared would result in 9a minus 1 and 9a plus 1. And I'll leave the rest for you to figure out. Oh, actually, I'll do this one because this one's a little trickier. Square root of 64 is 8. Square root of 9 is 3. Square root of a squared is a, and square root of b squared is b. And then we'll just mirror that with a positive 3ab. Now, difference of squares involving a common factor. Sometimes you'll get something like this, where I can identify a coefficient that's not a perfect square. So for example, 2, and 50 is also not a perfect square, but they do have 2 in common. So if I were to factor my 2 out, this would result in a squared minus 25, which reveals my perfect square. So my final answer, after I factor this perfect square, is going to be a minus 5, a plus 5. Here I can take out 3x, again revealing my perfect square. That would result in x squared minus 9, and my final answer of 3x, x minus 3, x plus 3.